You wake up tomorrow morning. You feel fine. You're alive. Your body still has water in it. But when you turn on the tap, nothing comes out. You look outside. The river near your house is just a dry ditch. The lake is gone. Even the puddles from last night's rain have vanished. Every drop of water on earth, oceans, rivers, lakes, rain, has disappeared, except the water inside you. You're alive. You're thirsty. And you're about to face the hardest survival story imaginable. At first, it doesn't feel like a crisis. You're not dehydrated. Your body is fine. But panic spreads fast once people realize there's nothing to drink, nowhere to refill. Grocery store shelves get stripped of bottled water within hours. Anyone who had water stored at home suddenly becomes incredibly valuable or incredibly at risk. This isn't just an inconvenience. It's the beginning of the fastest countdown humanity has ever faced, because a human being can only survive a few days without water to drink, even if the water already in your body is untouched. Without water, farms fail almost immediately. Crops wilt and die within a day or two, since plants can't survive without soil moisture. That means food supplies collapse right alongside water supplies. A double crisis, not just one. The sky changes too. No oceans means no evaporation, which means no clouds and no rain, ever again, unless something changes. The air grows drier by the hour. Dust replaces mud. Rivers that once carved through the landscape now sit as empty scars in the earth. This is where human ingenuity kicks in. With every external water source gone, survival now depends on finding water trapped in unexpected places. Underground aquifers deep enough to have been sealed off from surface evaporation might still hold trapped moisture, meaning deep drilling becomes one of humanity's only lifelines. Frozen water vapor, if any remains in the upper atmosphere, could theoretically be captured with specialized condensation technology, though it wouldn't be nearly enough to sustain billions of people. Some might turn to the last resource nobody wants to think about, recycling water from the human body itself, filtering and reusing every possible drop. The same emergency technology already used on the International Space Station, where astronauts recycle sweat, urine, and even breath moisture back into drinking water. As days pass, survival stops being just a science problem. It becomes a human one. Communities near any remaining water source, real or recycled, would face impossible decisions about sharing, rationing, or defending it. Governments would likely shift entirely toward water logistics, deploying every resource toward emergency drilling, filtration, and rationing systems. Meanwhile, humanity's greatest advantage isn't strength, it's cooperation. Historically, in real droughts and famines, communities that pooled resources and organized fairly survived longer than those who didn't. If deep earth water reserves are found, or filtration and recycling technology scales fast enough, a small percentage of humanity could realistically hold on, not comfortably, but alive. Over years, if underground water slowly seeps back to the surface, or new precipitation systems can somehow restart, the planet could begin, very slowly, to heal. But it would be a different world, smaller, more careful, far more aware of just how fragile the balance of water really is. This thought experiment isn't really about the water disappearing, it's about what's revealed when it does. Our bodies, our survival, our whole civilization, all quietly depending on something we almost never think twice about.